Well, thank you all for being here today. We'll be talking about going from chaos to clarity, debugging microservices with open source observability. And Sandeep.
Hello, everyone. I'm Sandeep, and I work as a lead software engineer at Norton. I think, so basically, neither in a hashtag engineer, that is not my actual designation, but that is what I do most of the time. Most of the times, I'm called to troubleshoot and debug microservices, a plethora of microservices where we don't know where is the problem, which service has the problem. And so I spend most of my time trying to find the needle in the haystack, and that is why I put that. And also, I'm the co-chair of the CNCF Dev and the Hard of Hearing Working Group. Over to you, Victor.
Hi, I'm Victor Prechtel. I am an engineering manager of cloud infrastructure at Powerflex, focused on renewable energy and EV charging. Fun fact about me, I ran my first full marathon last month at 40 years old. Pretty pumped about that. But I am also a member of the Merge Forward Deaf and Hard of Hearing work group, and that's how we met. So we'll get started today. We'll talk a little bit about the reality of microservices. Microservices, as you all know, are powerful, but they come with real challenges. Services fail independently and oftentimes silently. Your front end might be fine, but somewhere deep in your stack, a service is timing out, or you have cryptic log messages. So with microservices, a single request can touch 10, 15, 20, or more services, and each request can take on a different journey. Try debugging that with traditional tools. And when something breaks in the middle of the night, figuring out what went wrong can feel like archaeology. You're digging through those logs, bouncing between different services, and trying to put together the pieces of the puzzle for something that might have happened hours ago. Even worse, when there's a problem, you can't just simply pause production and your task to debug it. You have to figure it out while the system is running and the users are waiting for you. So what do we do? Well, that's what we're here to talk about. So our goal for today is to take you on a journey to build the skills that you need to debug real microservice failures to find clarity in the middle of chaos. We will start by simulating 2 different real-world incidents in a microservice application and walk through the process of diagnosing and resolving them. Along the way, we will use open-source tools to show step-by-step how to approach these failures, not just by fixing the symptoms, but by understanding what is really happening beneath the surface. Most importantly, we will focus on the fundamental strategies to make debugging effective, because at the end of the day, the tool will change, but the approach to gaining clarity stays the same. But before we dive into the demo, let's take a minute to build a foundation of understanding around observability, the key to seeing what is happening inside complex systems. So when something goes wrong in production, our first question is usually, what's happening? What's happening? But to actually fix it, we have to understand why it's happening, and that requires visibility into our services. And that is where the 3 pillars of observability come into play. Metrics are the heartbeat of the system. They tell us when something starts to go wrong. Through numbers over time, like CPU usage, request latencies, or error rates. They are great for detecting changes and spotting trends, giving us that first clue that something is off. So logs tell us the story behind those numbers. They are the detailed records of the events that help add context around what happens. You can think of logs as the narrative of the story. When there are spikes in those metrics, logs can help explain what caused it and turn that spike into something we can understand and act on. Traces connect the dots. Traces connect the dots around services to show us where a problem occurs. So traces are like the GPS coordinates of a route that you take, and it helps us build a map of the journey of a request from start to finish. They will reveal the relationships and dependencies that we might not see otherwise. So when systems fail, it can feel chaotic. The alerts will fire, your tickets start to pile up, and everyone is scrambling the furnaces. But when you have all these pillars work together, we move from guessing to knowing. So now that we understand the pillars of observability, let's take a look at some of the open source tools that we have chosen to bring those pillars to life in our platform. So Prometheus powers the metrics and alerting. It collects time series data, again, like memory consumption, request latency, CPU utilization, and error rates from across our systems. We use Prometheus to measure the heartbeat of our environment and answer that all-important question, when does something go wrong? It doesn't just collect data, it helps us spot trends, define alerts, and respond before users ever notice an issue. So next, we bring OpenTelemetry into the picture. And that brings to us traces. So OTel helps us understand how requests move across our microservices and external dependencies, giving us a detailed map of each request journey. OpenTelemetry is vendor neutral, and it integrates seamlessly with multiple observability stacks, allowing us to connect metrics, logs, and traces into one cohesive view. So finally, we have Linkerd. Our service mesh visibility layer is a lightweight control plane that sits between services, handling traffic, retries, and health checks automatically. What makes Linkerd so powerful is that it gives us real-time observability built directly into the communication layer of our stack. We gain metrics like request success rates, latency, and traffic volume, all without changing a single line of code. So in other words, Linkerd gives us X-ray vision into our microservices.
And so, while here we are using Linkerd, Prometheus, OpenTelemetry, and Jaeger, the principles that we are going to discuss in today's talk are universal. You can apply it to any microservice architecture. Okay. So with that, I'll go to the demo. And just a short note, I'm hearing impairment and I lip read. So if you saw me looking on the phone all the time, I was not preparing my notes or anything. I was just reading the captions that my co-speaker was speaking. So for the demo, I think, okay. So here is a small demo that is supposed to mimic the real-world use case. In real world, you have 15 to 20 microservices. So for simplicity, I built 5 microservices in Kubernetes. Okay? And so one of them is that the front end is written in Node.js. And then it is a simple bookstore demo, which lets you search for a book. So for example, you can search for your favorite Harry Potter book. So the front end gives you the ability to search. And then when you search, the front end contacts the catalog service. So the catalog service is actually written in Python. And then the catalog service in turn calls the inventory service, which is written in Go. So the inventory checks if the stock on the book that you are searching is available or not. And then how does the inventory work? It connects to the PostgreSQL database. And then we also have a payment system, like the user is interested in buying a book and the user checks out. So the user makes a payment, and the payment connects to an external service, like say Razorpay, like Stripe or something. So for external service, I'm using a fake API. So I have 5 different microservices which basically resemble a polyglot architecture. And now I'm going to take you to demoing some failures. And we are going to see how we are going to debug and troubleshoot the failures in real time. The failures are somewhat simulated, but you can basically mirror them to real time. So, okay. So here, I think that the problem is that the users are complaining about the slow response. Okay, so let us actually see what happens here. Okay, so I have this application, and I'm clicking here on the browse box. So you see here, it is loading and loading and loading. So basically it takes a few seconds of time. Now I'm going, in order to show you the metrics, I'm basically So this is a 100% offline setup. I've set up all of the polyglot microservices in my local client cluster. There is no internet connection using Binja. So I think, okay. Thank you for pointing out. Okay, you can all see it properly? Okay. So yeah. Okay, so this is a very small demo application, and I'm going to show you two use cases. One is a user is browsing the books, and the second one, a user is checking out and making a payment. So if I click on the browsing books here, you can see it loads and loads and loads. And then it eventually shows you the Harry Potter book, but it basically takes about 4 to 5 seconds. Okay, so in order to simulate this failure, so this is a 100% local client cluster, and okay, so here I have the catalog service here. Catalog, the database, front end, inventory, and payment. And so one of the things that I want to point out here is that, see in the catalog you are seeing 2 ports. That is because of high availability. But why are you seeing here 2 out of 2? That is because when I set up the service, the Linkerd is injecting a sidecar. So basically, one is the catalog service and one is a sidecar to monitor the metrics of the catalog service. Same way, for the front end, we have a sidecar to monitor the metrics of the front end service. So Linkerd, when I set up, is injecting the sidecar proxies. Now let's run. Okay, so one thing that is that it basically simulates what you saw here. Like you saw here, and it took about 4 seconds, but this basically simulates in a loop, so that I could basically show you the metrics in the Linkerd dashboard. Okay, so we go to the bookstore, and you saw it is mesh 10 out of 10. So basically, all the services are meshed here. Okay, it's beautiful. See here, see. One that this tells you that for the catalog service, the P50 latency is 1 millisecond. That means 50% of the users for 50% of the requests are working fine. But the P95 latency is a whopping 8 seconds. It means 5% of the requests are taking a very long time. And then P99 is 1% of the requests are taking even more longer time. Okay, so now that we saw this matrix here, yeah. So in case my UI doesn't work, I also had a backup here. So you can see here the stats here. Okay, so when the Linkerd shows us that where is the problem, the Linkerd told me that the problem could be either in the catalog service or in the inventory service. So the beautiful thing about Linkerd is that without writing a single line of code, it injected sidecar proxies, which allows me to get the metrics. Now I know the metrics. The metrics are stored in Prometheus, and Linkerd internally uses Prometheus. So now I know where is the problem, okay? But how do I know what is the problem? How do I find out what is the problem? So for that, I'll go to Jaeger. So Jaeger, OpenTelemetry, all of that instrumentation is basically, Jaeger is a visualization tool for OpenTelemetry tracing. So here, I have selected front-end services, and then I think I'm going to just select the last 5 minutes. Okay, and I'm going to click on Find Tracing. Okay, so I got 19 tracing. So let me check one trace, get books. So get books is basically what happens here. When you click on the browse books, it's basically going to the get books. So let us see the expansion. So what do we see here? Okay, so the first thing is that this is the trace here, 5203CA. Now the single trace is single trace for multiple microservices. A single trace ties up all the microservices. And now you see here, the front end calls catalog, the catalog then calls inventory, the inventory calls the database. Okay, good. Now let me see what is the problem here. Okay, in the database query, then we have the tags here. Okay? Here. Let's just tell you what is the problem. It is right in front of you. db.index is false. What it means is that you are basically firing a like query over millions of records, and there was no index on the database. So while this is a very simple use case, what I want to demonstrate is that this is a very powerful tool to basically filter and narrow down where exactly is the problem. Everyone clear on this? So this clearly shows that this database does not have an index, and that is why searching is taking a long time. So how would you fix it? Basically what you do, you just create an index. That's it. You redeploy, and then you should be good. So that brings to an end of the first demo, and Victor is basically going to run you down through a quick summary of what we did.
Awesome. So, thanks, Sandeep. Let's recap for a second what we discovered in the demo. So starting with Linkerd, we found that the inventory service had a P95 latency of more than 4 seconds, which means 95% of all requests to the inventory service were taking greater than 4 seconds. This didn't paint the entire picture though. Next, we used Linkerd to see that the inventory service to the database had a 100% success rate. So there were no failures there, but every request was slow. So this told us that this wasn't an infrastructure issue. This was a latency between services issue. The service mesh helps us narrow down our focus from something as slow to this query is the bottleneck. So we then used Jaeger to discover that the database query itself was taking most of the entire request time. So when combining metrics and tracing together, we got a better picture of the root cause, a missing database index. So every query was scanning an entire table with millions of rows. Once we added the index, the response time will drop from 8 seconds to, say, 50 milliseconds. This is observability in action. We started with a broad metric to identify when something was wrong, use the service mesh to pinpoint exactly where it was happening, and finish with tracing to uncover why. So each pillar of observability gave us different lenses. And together, they turned hours of guesswork into minutes of confident diagnosis. So the first scenario showed us how observability helps us solve a slow but consistent latency problem. But not every incident is that straightforward. Let's be honest. The painful issues are the ones that come and go. For scenario 2, we have users who are randomly getting 500 errors during checkout. Not every time, just occasionally. That unpredictability makes it hard to test, hard to diagnose, and even harder to prove that you fixed it. Only about 10% of these requests are failing. You try it yourself, and it works fine. Logs, they don't show anything useful, and because multiple services are involved, it's not even clear where the problem starts. So the question becomes, where is this failure happening? Is it the front end timing out? Is it the payment service failing? Or is it something downstream? Sandeep will take it from here and dive into the scenario.
So these intermittent failures are the hardest to debug because you cannot reproduce it. The first thing when you see an issue is you try to reproduce. And when you cannot reproduce something, it is very frustrating. So we are going to try with a second thing, and I think my demo works, yeah. Okay, yeah. Okay, so what it does is that, as you can see, it is trying to basically simulate some payment failure. And I just hope it works. Okay, so if you see an X, it means a failure happened. Okay, and if you see a dot, it means a success happened. So I'm basically going to show you the logs here. Okay, so you see here? Okay, so the logs basically tell me, but here, I actually wanted to show you something else here in Linkerd. I think. Okay, see here. See here. You can see here the Linkerd is very clearly showing me that the payment thing is failing. Okay, so this metrics helped me immediately narrow down that my payment is having like basically an 81% successful rate, which means approximately 19% of the requests are failing. This in production is absolutely unacceptable. So Linkerd helped me to narrow down, and then I think we can again go back to Jaeger, and we'll try to see if the UI actually shows us what is the problem. And the last time I tried, here is that. We have got 4 errors. Beautiful. Yeah. And here, if you see here, yeah, it says the socket timeout exception. And we can basically correlate this with the log. It's basically. But see, the thing is that you will tell me that you already knew the failure was in the payment service. That is because I set up the demo. In real time, you would not know that the failure is in the payment service like that. I was still in the payment service because I knew payment service has the problem. But in real time, you will basically see the Linkerd in dashboard, find out which service has the failure, and then you will tell the log. So this brings us an end to the session. And I think I'll quickly tell something. I have a story to share. So there was a ship, and the ship's engine broke, and no engineer could fix the ship's engine. So then they searched a lot, and finally one old man came. One old man came, and that old man came with a set of tools. And then he quickly went and inspected everything, and then finally understood the problem. He went from his big tool kit, he took out one hammer, and then he tapped, and the ship's engine started working. He sent a bill of $1,000. When the owner asked to itemize, he said, $2 for tapping with the hammer, $998 for knowing where to tap. This observability step is about knowing where to look for. Thank you.
So we're going to kind of jump through this really quickly, but in the end, what we discovered is obviously is using the right tool to solve the problem. Using the right tool to solve the problem really help us find where the actual root of the problem is. So what are some of the debugging strategies? You can start with metrics, get the big picture. Use your service mesh to understand the service interaction. Dive into your cases to find the exact failure point, and then confirm that with your log. And when you bring all of those together, you get a good idea of exactly what's going on in your microservices. So when we talk about observability, the foundational principles that work everywhere, regardless of what software you use. The tools may differ, but the principles remain the same. Prometheus could be CloudWatch, or Datadog, or Grafana Cloud. Patterns are transferable. So you can use the same debugging flow in any environment. Observability is a practice. Build it into your architecture from day one. So this kind of talks a little bit about the story that Sandeep just went over. And then lastly, I want to take a moment to talk a little bit about Merge Forward. It is a new initiative within CNCF. It is home to the new and old community groups such as the Deaf and Hard of Hearing work group, Women in Cloud Native, Neurodiversity, and many more. So the primary goal of Merge Forward is to build a diverse and sustainable cloud native community where everyone feels welcome and seen. So Merge Forward is doing this by working together, working hard to build strong, supportive networks to connect community members from diverse backgrounds and allies. So thank you for your time. We hope some of these strategies help you debug faster and sleep better. Feel free to connect with us on LinkedIn or stop us in the hallway for a chat. We will be sharing the demo code and complete setup instructions later. Everything shown today will be on GitHub. I don't know how long it'll take, but we'll get there. But yeah, if you have any feedback, please share them with us. Thank you.
Thank you. Thank you.